Hi, so in this video we're going to learn some more trigonometry identities. So let's get started. So in this video we're going to go over trigonometry identities called Pythagorean identities. And a trigonometry identity is just a rule in trigonometry that relates to trigonometry ratios. So for example, tan theta equals sine theta over cosine theta relates through two or more trig ratios, and so it's called a trigonometry identity. And in this video we're gonna go over trigonometry identities called the Pythagorean identities. So the way these identities work are because of the Pythagorean theorem. So here's my right triangle, and we're going to use the Pythagorean theorem on it. So this is the opposite side to the angle theta, and this is the adjacent side to the angle theta. So using the Pythagorean theorem, we can write O squared plus A squared equals H squared. Okay? And then what we're going to do is we're going to divide both sides by H squared. So we have O squared over H squared plus A squared over H squared. And then H squared divided by H squared is just 1. But this we can rewrite as O over H squared plus A over H squared equals 1. Because O squared over H squared is the same as O over H squared. But what's O over H? Well, that's opposite divided by hypotenuse, which is just sine of theta. So that means we write that the sine squared of theta, or the sine of theta squared, and then A over H is just adjacent over hypotenuse. So that's cosine theta. But that squared is cosine squared theta, which is the cosine of theta squared. So that means, using the Pythagorean theorem, O squared plus A squared equals H squared, we have a new trig identity, sine squared theta plus cosine of squared theta equals 1. And instead of writing cosine of theta squared, we write cosine squared of theta. So that's the first Pythagorean trig identity. The sine of theta squared plus the cosine of theta squared equals 1. So that's one important trigonometry identity. And then the other ones come after you divide by... So now we're going to divide both sides by adjacent, so A. If we divide both sides by A, we get O squared over A squared plus 1 equals H squared, because, we're going to divide both sides by A squared. So O squared over A squared plus 1, because A squared divided by A squared is 1, equals H squared over A squared. And again, we can rewrite that as O over A squared plus 1 equals H over A squared. But what's O over A? That's opposite over adjacent, which is just tan theta. So tan squared theta plus 1 equals, what's H over A? Well, in my last video we went over the reciprocal trig ratios, and this is the reciprocal of cosine, because it's hypotenuse over adjacent instead of adjacent over hypotenuse. And the reciprocal of cosine is secant. So this is secant squared theta. So this is the second Pythagorean identity. Tan squared theta plus 1 equals secant squared theta. And then you can rearrange it to solve for any tan or secant. So that's the second Pythagorean identity, tan squared theta plus 1 equals secant squared theta. And then the last trig identity comes from dividing both sides by O, or opposite. That means 1 plus A over O squared equals H over O squared. Well, A over O squared is the reciprocal of tangent, which from my last video is cotangent. So this becomes 1 plus cotangent squared theta equals H over O is the reciprocal of sine, which is cosecant. So 1 plus cotangent squared theta equals cosecant squared theta. And that's the last Pythagorean identity. So that's it for this video. So all we did in this video was use the Pythagorean theorem on a right triangle to find the Pythagorean trig identities. And I'm just going to rewrite them. So we've just found that sine squared theta plus cosine squared theta equals 1. 1 plus tan squared theta equals secant squared theta, or secant of theta squared. And then 1 plus cotangent squared theta equals cosecant squared theta. So these are the three Pythagorean trig identities. And that's what I wanted to go over in this video. Hope you like this video.